all the light we see from stars, just like our sun and every star that you see at night, all from the energy in the center of a star because of its huge temperature and pressure.
Ding dong ding.
Okay, so astronaut question we answered. The moon question we answered. Why do stars shine? We got that one. Okay, so now about traveling out to a galaxy. I love that question. So I did a little research because I wanted to calculate how long it would take for astronauts to reach the closest galaxy. So first I need to tell you about how we measure the distances to stars and galaxies. So we use this measurement called a light year. It's a really, really long way. It's the distance that light can travel during 1 year, which in miles is about 6 trillion miles. Okay, so each light year is 6 trillion miles. The closest star past our sun is about 4 light years away. So 24 trillion miles just to get to the closest star. And that's inside our galaxy. That's inside the Milky Way. And that's the closest star to us. So if we hopped on the fastest spaceship we have right now, it would take us 80,000 years just to get to the closest star. 80,000 years just to get 4 light years away. Well, the closest galaxy outside the Milky Way is over 2 million light years away. So you have to do a little math, and you have to take 80,000 and multiply that by 2 million. And that'll tell you the number of years it would take to travel to the next galaxy. So we're talking about billions of years. So you couldn't actually get there in 1 lifetime. You couldn't get there in 2 lifetimes or 3 lifetimes or 4. It would take millions and millions of generations of people all traveling on the same spaceship so that one person could make it all the way to the next galaxy billions of years later. So it's going to be a long time before we're able to travel even to the closest star, let alone the closest galaxy with the technology that we have right now.
What happens if you take a spaceship out of Earth and then you float to the nearest star?
Yep, it would take about 80,000 years. And that's traveling at the fastest speed we know how to travel. If you were just floating, it would take you hundreds of thousands of years, maybe even millions of years to get to the next star.
Oh.
Yeah. So let's see. There were a couple other questions about where do rocket ships land and what do astronauts take with them when they go on rockets. So it depends. We land rockets in lots of different places. We've landed spacecraft on the moon. We've landed spacecraft on Mars. We've sent spacecraft to out to explore the moons of Jupiter and Saturn. And so we can land spaceships all over the place. The only place that humans have landed has been on the moon, but that's going to change sometime soon. There are new plans to send people out to Mars in the next 20 or 30 years. So when you guys are my age, there'll probably be people living on Mars, which will be pretty cool. But right now, we've only landed people on the moon. But spacecraft have traveled all over the solar system, and there are a couple special spacecraft that are actually outside the solar system. They're called the Voyager spacecraft. They're so far away that they're past Pluto, out into interstellar space. And they're some of the fastest spacecraft that we have. And it's going to take them tens of thousands of years to reach the closest star. But they're really, really far away now. So
Dr. Sam, we have some first graders that have written some questions that I didn't send to you.
Oh, great.
So maybe Mrs. Gragg can call on those kids and have them ask their questions?
Yeah, that'd be awesome.
Okay, good.
All right. I can't see the kids from here, but I'll just call out a name. Sophia, do you have a question for Dr. Sam? Sophia, are you there? Because I can't see anybody.
Yes.
All right,
Okay.
girlie. Ask your favorite question that you wrote. You wrote some really nice one. I think they wrote about 3 to 5, Dr. Sam.
That's awesome.
Go ahead, Sophia.
How many galaxies are there?
Oh, great question. Here, I'm going to bring up a slide. Okay, so this is a question that somebody asked me before about how many stars are there. And to come up with the answer to this question, I had to know the number of stars in every galaxy and the number of galaxies. And then I multiplied those two numbers together to get this answer. So first, to answer your question, we think that there are about 1 trillion galaxies out there in the universe. 1 trillion galaxies. So the galaxy that we live in, the Milky Way, is just one of those. So in those 1 trillion galaxies, the average number of stars is about 200 billion. So I multiplied 200 billion times 1 trillion, and this was the number that I got. So if you added up all the stars in the universe, they would add up to this number. And the name for this number is 200 sextillion. That's how many stars there are in the universe, if the average number of stars per galaxy is true everywhere, which we think it probably is. So 1 trillion galaxies, 200 billion stars in each galaxy, so 200 sextillion stars in the universe.
Wow.
Great question.
That's awesome. All right, let's go to Janya. You have a question?
Yeah.
Okay, nice and loud.
What is the black hole made of?
What is a black hole made of?
Yeah.
Oh, cool. I got a slide on black holes too. Let me bring that
Of
up.
course you do.
Let's see here. There we go. So you guys probably know this. Astronomers took the first picture of a black hole just last year. Nobody really knew what a black hole looked like until we got the first picture last year. And I've got the picture. So there's the actual picture of the black hole that was photographed last year. And we think that if we were up close to the black hole, it would look like this. But because we're so far away and because they're so small, it looks really fuzzy. So they look more like this. But if we were up close to it, it would look like this. And so what you're seeing there is a couple different things. And this will answer your question about what they are and where do they come from. So all of the orange lines and all of the yellow light that you see making this kind of weird bell shape, that's called the accretion disk. You can imagine it as kind of an asteroid belt around the black hole. And not all black holes have that accretion disk, that asteroid belt, but a lot of them do. And the one that we photographed did have one of those. And it turns out that's really all you can see around a black hole. You can't actually see the black hole itself because they don't let out any light. All the light that comes into a black hole gets sucked into it and it can never escape. So it's only the light that's moving around the outside of a black hole that we actually get to see. And all this light and all this stuff out here is all the stars and planets and gas and dust that are getting broken apart and sucked into the black hole. But before they get sucked in, they let off a lot of light, and we can actually see it as they're spiraling around the black hole, about to get sucked in. So that's what we're seeing there. The black hole itself is inside of that, the spot where you can't actually see anything because it's totally black. And what it actually is a part of space that has an object. So it's a real object that has weight, that has mass. There's so much mass crammed into such a small little space that what's called the escape velocity is greater than the speed of light. And I'll explain what I mean by escape velocity. So you guys have already asked questions about rocket ships. So you know that rocket ships have to travel really, really fast to get off the Earth. For a rocket ship to get out of the Earth's gravity it has to travel 25,000 miles an hour, which is really fast. When you're in your parents' car, maybe you travel 60 or 70 or 80 miles an hour. So you'd have to be traveling 25,000 miles an hour on a rocket ship to get out into space. If you were on a rocket ship next to a black hole, you would have to travel faster than the speed of light to leave the gravity of that black hole. And that's why we can't see them. Even traveling at the fastest speed in the universe, the speed of light, you can't actually get away from the gravity of a black hole. It pulls you back. And that's why they're black. That's why we call them black holes. They've got so much mass that gravity is so strong that nothing can leave them once they pass a certain distance from the center of a black hole. And we call that special distance or that area the event horizon. So once you pass the event horizon, there's no coming back. You'll be inside the black hole forever. And so all this light that you see outside is just beyond the event horizon. And once it crosses the event horizon, we won't be able to see it anymore. How they form is kind of a tricky question to answer. Some black holes can form when a star dies. When stars get really old, they run out of all the fuel that they use to shine, like we learned about earlier. And when they run out of all that fuel, they collapse. And sometimes they can collapse all the way down to a black hole. And those are called stellar mass black holes because they're roughly the size of really, really big stars. And those black holes are kind of scattered all throughout the galaxies in the universe. There are thousands of them in the Milky Way galaxy and in lots of other galaxies as well. But the black hole that got pictured, we took a picture of it last year, is not one of those stellar mass black holes. It's a really special type of black hole called a supermassive black hole. And supermassive black holes are only found in one special spot in galaxies, in the very center of galaxies. And those black holes are way bigger than the other black holes that form from collapsed stars. The supermassive black holes are as big as billions and billions of stars. And to be totally honest, astronomers don't know how those black holes formed. We think it had to do with a bunch of stars all collapsing together, but we really haven't figured out the math of how to make that theory work. They appear to be too big for all the stars that we can actually think might have fallen in to form one of those giant black holes. And so maybe that's a question you guys can answer when you become astronomers, how those really big black holes formed, because right now astronomers really don't know. That's a great question.
Wow, awesome. Let's go to Penny. Penny, do you have a question? Penny, are you there? Hello? I can't
You
see.
can pick me, Mrs. Wag. It's okay.
I picked Penny. Is Penny there?
How old is the universe?
How old? Yeah,
Did you-
that's a great question. So we think that the universe is about 13.84 billion years old. But that's just our universe. There might be other universes as well. We're not totally sure about that. Let me see if I can bring up this other slide that I have about the universe, and it'll tell us a little bit about how big the universe is and about how old it is. And this will give you a little bit more understanding on what I'm talking about.
How big is the universe? Everywhere you look, there are stars. These are in our galaxy, the Milky Way. Light takes 100,000 years to cross our galaxy. If the whole of our solar system, including the vast bubble of comets surrounding us, was the size of a toilet cubicle, the Milky Way would span the distance from Greenwich to Maidstone. Beyond the stars are even more star cities, galaxies of different shapes, colours, sizes, stretching out across space for billions of light years. The closest big galaxy to us is Andromeda. If we sent a text message out to aliens in Andromeda, it would take 2.5 million years to reach them. When we look at galaxies through our telescopes, their light might have taken millions or billions of years to reach us, by which point they would have aged and they might not even exist anymore. It's as if we're trapped on a desert island. We experience a horizon in all directions beyond which we can't see anything. However, our cosmic horizon is receding all the time as light eventually reaches us from farther and farther galaxies. This is like waiting for photos to be delivered to us from distant parts of the Earth whilst on our desert island. Unlike our earthly ships, light travels at a whopping speed of 300 million meters per second. But even light takes a finite amount of time to reach us, and this sets our current cosmic horizon. What can we actually see with our telescopes? Well, we can't see light from the birth of the universe. The early universe was a very hot, small, dense place where light continuously bumped into matter. About 380,000 years after the Big Bang, the universe was large enough and cool enough for atoms to form and for light to travel freely through space. This includes the ancient radiation from the Big Bang, which we can see in all directions. After about 200 million years, the first stars formed, and then galaxies, and then eventually the Milky Way, including our solar system. If the lifetime of the universe was a 10-hour movie, humans would only appear in the last second of the film. Remember, during all this time, the universe has been continuously growing over a period of 13.8 billion years. That's 3 times the age of our solar system. So does this mean that the universe is 13.8 billion light years big? The answer is no. When light first left a faraway galaxy, it was much closer to us, but over time, the universe has expanded like a huge balloon. So the light has taken longer to reach us. Over large enough distances, space can expand faster than the speed of light.
So you guys can't hear the sound?
Yeah.
You can?
Yeah.
Oh, okay.
Yeah, I'm not on the scene where I can't even see the video.
You can't even see the video. Uh-oh.
Okay, what happened?
I can hear it and see it perfectly.
Back.
You can?
I can
Yes.
hear
Okay.
it perfect too, like Mrs. Kirby said.
Okay, I just wanted to make sure. We'll play it again.
Okay, Kay.
Can you wait for me?
Yeah, Kay, do you have a question for Dr. Sam? Kay.
Why is there no gravitational force in space? Just wait for that. I'm getting on the back of the screen.
Okay.
Yeah,
I
so
can see it now.
so gravity is all about mass. And so wherever you have mass, like the Earth or a star or a black hole, you have gravity. But if you're really, really far away from the Earth or a star or a black hole, then you wouldn't experience any gravity. So you have to be really close to something big to feel gravity. Just like when you're standing on the Earth, it holds you there. And just like if you were close to a black hole, it would suck you in. And just like the Earth moving around the sun, it's the sun's gravity that holds the Earth in orbit around the sun.
Will it digest you?
What's that?
Would the black hole digest you?
Not exactly digestion like your stomach does. What it would do is spaghettify you. That's the term that we use when you fall into a black hole. You get spaghettified. And the reason for that is the part of you that falls in first gets stretched out compared to the part of you that's falling in last.
And then you'll die.
Eventually, yeah, it would stretch you all the way apart, and then it would separate all of the pieces of you from all the other pieces of you. But then in the end, when you got down to the center of a black hole, it would crush you really, really tightly. Yeah. Probably wouldn't be a fun thing to fall into a black hole.
No.
Thank you.
Thank you, Cade. All right, let's go on to, let's see, Javon, do you have a question for Dr. Sam?
Yeah, yes.
Okay.
Did Pluto used to be an asteroid?
So Pluto used to be a planet, and now poor Pluto is just a dwarf planet. Let me see if I can find my Pluto slide. Oh yeah, here we go. So we used to think of Pluto as a planet, But back in 2006, astronomers decided to create a whole new category of objects called dwarf planets. And Pluto became one of the first dwarf planets. And there are lots of other dwarf planets out by Pluto as well. There's Ares and Makemake, Haumea, Sedna, Quoar, Orcus, and they're all these tiny little rocks way, way far away in space, way past the orbit of Neptune. And so you can see the size of them compared to the Earth down here. They're much, much smaller than the Earth, much, much smaller than the moon, actually. And all of these objects exist in an area that we call the Kuiper belt. So it's kind of like the asteroid belt, but it's much, much farther away, way past the farthest planet, Neptune. And we think there are probably thousands or even millions of dwarf planets out there. We just haven't discovered them yet. We just know of about a dozen dwarf planets right now. Yeah, so Pluto got kicked out of the Planet Club because it wasn't big enough. Now astronomers think there's a size limit for planets, and Pluto was just too small.
Well, thank you, Javon. Let's see. Let's go to Evelyn. Do you have a question? Evelyn?
Yes.
Yeah. Why does Saturn have rings?
Ooh, that's a great question. I don't know if I have a picture of Saturn in this presentation. Maybe I can find one real quick while I'm talking. So Saturn has rings because a long time ago, billions of years ago, when Saturn was first forming, there was probably another really big moon that was forming around Saturn that was too close to Saturn. And Saturn's gravity broke the moon up into billions of little tiny pieces. And all those pieces kept on orbiting around Saturn. So that's one possibility. The other possibility is that while Saturn was forming, and while most of the other moons of Saturn were forming, there was a lot of stuff close in towards Saturn, and it was just too close to form into a moon. And so it just stayed as those rings. It was too close to Saturn, too close to Saturn's gravity for a moon to form. So one or the other. Either a moon got torn apart, or it was just too close for a moon to form. But we're not sure which.
Okay, awesome. All right, let's go on to, let's see, Keon, do you have a question? Keon? Keon, are you there? All right, talk nice and loud. Give us your question.
Black holes lead to?
Where do
Say
they
that
lead
again?
to?
Oh, where they lead?
That's a great question. And the honest answer is nobody really knows for sure, because there's no way to actually see inside a black hole. And so we've got a couple different guesses of where black holes lead to. One guess is that at the center of a black hole, there's what's called a singularity. A really, really tiny, 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 tiny little space where there's a huge amount of mass all crushed down into it. And that's where everything would stop once it's falling into the center of a black hole. And it would just get crushed down into this tiny little space called a singularity. So that's one possibility.
Is that how Saturn got its rings?
We'll get to that question in a minute. Let me finish answering this one. So the other possibility with a black hole is that it might actually be a portal to another part of the universe. There are some people that think that you don't actually get crushed into a singularity. You'd actually come out the other side of somewhere in space outside of a white hole, which is the opposite of a black hole. But let me be clear that we've never actually seen white holes, nor have we ever seen the type of matter that we would need to actually have one. So they're just theoretical, but that's the other possibility of what might happen if you fell into a black hole. They might actually be these things called wormholes that could take us to some other part of the universe that we can't see. But more than likely, it's a singularity.
Awesome.
Great question.
Okay, Parker, do you have a question? Parker? Parker, are you there? Let's go on. Vanya, are you there? Do you have a
I'm
question? Okay, Parker, go ahead.
Yeah. Is the sun actually yellow, the color yellow?
No, that is such a good question. It's not. The sun is actually white. If we could go out in the space and it wasn't too bright for us to look at, we had really, really special glasses on, we could look at the sun and it would be white. The yellow appearance is just what we see through our atmosphere and because of the color that our eyes are most sensitive to. And so that's why it appears as yellow. But yeah, it's not actually yellow. It's a white star. I think I've got a picture of all the different colors of stars. Yeah, here it is. Can you guys see that?
Yeah.
Yeah, so our sun is right here. And this is all based on the colors we would actually see with our eyes. And so stars like our sun would appear yellow if we were orbiting around that kind of a star. There are other stars that would appear red, these tiny little stars called red dwarfs. There are also orange stars. And as you get to the redder end of the color spectrum, that's when stars are getting cooler. Stars that are reddish in color are not as hot as our sun. There are also red supergiants, really, really enormous stars, way bigger than our sun. But because they're red, they're not as hot as our sun either. To get to the hotter stars, they're the ones that appear more blue. So all these blue stars up here are really, really hot, thousands of times as hot as our sun. And if the Earth was orbiting around one of those stars, then the star that we would be orbiting around that we would see up in the sky would look blue. But stars actually shine in every color of the rainbow, and so they're actually all white because all of the color comes through at once. It's just that through our atmosphere and with our eyes, we see yellow for our star. Great question.
Oh.
Awesome. Okay,
So
let's go on.
are the blue ones called hypergiants?
There are blue hypergiants. Yep. The biggest of the bluest stars are blue hypergiants.
All right, Kate, let's let Ariana ask a question. Thank you. Ariana, you have a question? Ariana, are you there? Hello? Okay, let's go on to Daniel. Daniel, do you have a question? Daniel, do you have a question? Are you on? I know he's here. Daniel, do you have a question? Last call. All right, Vanya, do you have a question?
Yes.
Okay, go ahead, Vanya.
Can life survive on Mars?
Boy, I wish I could answer that question for you. I really hope there's life on Mars. But again, nobody really knows for sure. We don't think there's life on the surface of Mars because the atmosphere isn't very thick on Mars. And we don't think there's any water on the surface of Mars. But way down underneath the ground on Mars, there might be liquid water and there could be life. And so it's certainly a possibility that there's life living underneath the ground on Mars. And it's possible that it's there, definitely. Probably not on the surface. And my guess is probably within 10 or 20 years, we're gonna find some type of microbial life way down underneath the surface of Mars. So I think it's probably there. We just haven't found it yet. Great question.
Oh, that's awesome. Okay, Rhea, do you have a question quickly? Rhea?
It's okay. You can pick me. I unmuted.
Are you there now? Okay, thank you, Daniel. Go ahead.
Wait, I have a question.
Okay, just a minute. Let's do Rhea. Go ahead and go first. Thank you.
Wait, so do I only get one question?
Yes, right now you get one question. Pick the favorite question that you have. Quickly.
How was the Earth before the dinosaurs?
Great question. So before the dinosaurs, several 100 million years ago, there was a lot more water covering the surface of the Earth. There were these huge oceans all over the place. And the atmosphere was a little bit different. There was probably a lot more oxygen in the atmosphere then than there is now. And that's why the dinosaurs could get so big. There was a lot more oxygen, and that's why plants were a lot bigger as well. But just like everything changes, the Earth changes as well. And so right now, there isn't as much oxygen in the atmosphere, and plants are smaller, and a lot of animals are smaller as well. But you probably know that there was a huge asteroid or a huge comet that hit the Earth about 65 million years ago. And we think that's what led to the demise, the death of all the dinosaurs. Not just the impact of that big rock, but because of how much dust it kicked up in the atmosphere. It kicked up so much dust in the atmosphere that it blocked out the sun. And without sunlight, plants can't grow. And so all the plants started dying, and then all the animals that would eat those plants would start dying as well. And dinosaurs that ate those animals died as well. And so without sunlight, it's really hard for life to exist. And that's probably what happened about 65 million years ago. Great
Wow.
question.
All right, Daniel, you have a question for Dr. Sam?
Yeah. What
Okay,
would
go ahead.
happen if we go to the black hole?
Ah,
You're obsessed.
so yeah. So we talked about spaghettification before. So that's what would happen if you got really close to the black hole. If you actually got right up to the event horizon and then got
Like-
sucked in.
So close to the black hole.
Yeah. So if that's what would happen if you got past the event horizon, got even closer, you'd get spaghettified. But if you could stay far enough away, you wouldn't get spaghettified. And you'd see a really, really beautiful image, something like this, as you were getting close to the black hole. You'd see the part where stuff was in closer than the event horizon, where it was all black. But you'd see this incredible spiraling disk of debris getting sucked into the black hole. And you might even see these jets being shot out from up above and down below the black hole. So this is a picture of what we think the black hole in the center of our galaxy might look like. But it's really far away from us. So here we are right here in the Milky Way galaxy. And the center where that black hole is up there. And that's about 20,000 light years away. So even if we were traveling at the speed of light, it would take us 20,000 years to get there. But actually, just a couple days ago, there was an announcement made that the closest black hole to Earth was discovered. And it's only about 1,000 light years away, which would put it about right here. So now we know there's a black hole only 1,000 light years away from Earth. It's still a really long way away, but it's a lot closer than the really big one in the center of the galaxy. But yeah, you'd get spaghettified if you crossed the event horizon. If you stayed far enough away, you would get a really beautiful thing to look at. The other interesting thing that would happen to you is that time would actually slow down for you relative to everybody else back on Earth. And some of you maybe saw the movie Interstellar, or maybe not. But in the movie Interstellar, they get pretty close to a black hole. And even though they just spend a few hours around the black hole, it happens to take decades for that same amount of time to happen on Earth. So when they get back to the Earth, like 60 years have passed, even though it was just a few days or months for them traveling through space. So when you get into really, really strong gravitational fields, like around a black hole, time starts to slow down for you relative to people on smaller gravitational fields, like on Earth, where time passes much more quickly.
Awesome. All right, Ariana, do you have a question? Ariana, are you there? Can you hear me? Miss Singer? do you-
We'll have
Oh.
another favorite question.
Oh, well, just a minute, Daniel. Everybody has to ask one question. We're waiting for, please mute. Let's see, Ariana, are you there? Last one. I don't want you to be left out if you are here. Miss Singer, can you see her? I don't know. I don't see her. Okay, that is all of the first graders. If we can't get Ariana, I just want to make sure. I know she's here. Ms. Singer said she was here, and I know the first graders were so excited to talk with you and learn so much about space. We've been studying it for now about, what, 5 weeks already. So
Nice.
yeah, exactly. They've come up with a lot of questions. So Ariana, one last time, are you there? Okay, Ms. Singer? I don't know if she hears me either. Let me see. Singer, hello?
She's still muted.
Oh, is she still muted?
Yeah. I think you have to unmute her.
Okay. I'm not sure.
Hello, Miss Gregg.
Yes, hi.
This is Ariana's dad. Sorry.
Oh, is she there?
She just ran to the restroom. I'm going to try to go get her back.
Oh, okay. Okay, good. But we'll wait for her so that she can have her question.
Okay,
All right,
thank you.
Thank you. Okay, thank you, Mr. Seals. I know she didn't want to miss it.
Sweet. We can wait. That's fine.
Sam,
Yeah.
There you go.
Brooklyn would like to know if there's UFOs in the universe.
Ah, good question.
Yeah. So I'll answer 2 different questions. First, UFOs, and then about aliens, because they're 2 different things. So UFOs are anything that you see up in the night sky that you can't identify. So UFO stands for unidentified flying object. So anytime you see an interesting light whiz through the sky and you don't know what it is, that's a UFO. So I've seen lots of those at night when I've been out stargazing. There have been tons of weird lights that I've seen in the sky that I have no idea what they are. So by definition, those are UFOs. Whether or not they were aliens, I don't know. But right now, we know of about 4,000 planets that orbit other stars just in the Milky Way galaxy. Let's see, I thought I might have had, yeah, I do have a slide about that. So here's a picture of some artists' drawings of some of the planets that we've discovered orbiting around other stars. And you can see their size relative to the Earth and Jupiter, Neptune, and Mars. So there are a couple dozen planets that we've discovered that are similar in size to the Earth. They might have water, they might have atmospheres, and they're at the proper distance from their stars, from their suns, to actually make life possible. So we call them habitable planets, planets that have good habitats to live on. So I definitely think there's life out there on one of these habitable planets, and we've just started exploring. We've only looked at about 10,000 stars so far, and there are over 300 billion stars in the Milky Way galaxy. So there are probably billions of habitable planets like Earth in the Milky Way. So I think there are definitely aliens out there. We just haven't found them yet.
Or they haven't found us.
Or they haven't found us. They might be watching, you never know.
Right. He's waiting. Yes. Are we waiting for Ariana still? Because I have another question. They keep coming in.
Mr. Seals, is she coming back or not?
Oh, sorry, I just sent you a message. No, she ran out to her treehouse. Some friends came over, and 7-year-old for her to.
That's
run
okay.
into them.
All
Sorry
right. Well,
about that.
that's okay. Thank you very much. All
Yeah,
right.
you
Go
got
ahead,
it.
Ms. Singer.
So Liam wanted to know, Dr. Sam, if astronauts get burned by the sun when they go into outer space.
Yeah, did you guys see that movie I played earlier?
Yeah.
Let's see if I can come back to it. Let's see. No, that's not the right one.
He's answering the question.
Oh, there it is. Yeah, so here's that video again, but the short answer is they don't, because their spacesuits have special protection on them. And that protects them from all the UV radiation that our ozone layer normally blocks. And so, yeah, because of the special protection from their spacesuits and the special shielding that's up on the International Space Station, they don't get sunburned. But there's definitely a lot of UV radiation up there, a lot more than
They have a
than
special
what we
suit.
experience on Earth. But there are other problems. These things called cosmic rays, just the radiation that travels through space. And they also have to have special shielding to get protected from that.
You want time, so
Okay. All right, Miss Singer, I think we are.
Thank you.
You're
Welcome.
welcome, Liam. Okay, anybody else have a question they may want to ask at this point before we head off?
First graders, do you have, I know
Oh,
you
here
have.
we just got one.
Okay.
Does he want to go to space?
Oh,
You
yeah.
want to go to space, Dr. Sam?
Beam me up, Scotty. Yeah, I would love to go to space someday. And that actually might be a reality in the next 20 or 30 years. I think space tourism is a real deal. If Richard Branson and Elon Musk have anything to do with it.
Yeah.
So we may be able to take, 2-week-long trips to the moon and hang out for a little while before the end of my lifetime. So, or even just going up to the International Space Station, I think would be pretty cool.
Yeah.
Spend a weekend on the International Space Station. I'd definitely do that.
Yes.
I have another question.
All right, go Sophia, quickly.
How the solar system was made?
Great question. I have a picture of that on this slideshow. Let's see.
And then Alex, we'll get to your question right after Sophia, okay?
Let's see if I can find a good one really quick here. I know I used to have some really good. Oh yeah, here we go. I got one. All right. Let me bring up this picture here. And then I think I need to do a new share. Okay, here it is. Can you guys see that now?
Whoa.
Ooh, yeah.
Yeah, so this is a picture of the Orion Nebula. It's what we call a stellar nursery. And so these are huge clouds of gas. And it's the leftover gas and dust from a previous generation of stars. Stars that have already shined for a really long time, ran out of fuel, and then exploded. And all of their stuff just gets spread out through space. And eventually those clouds bump into other clouds, and those clouds start condensing and getting tighter and tighter and denser until they start forming new stars from the leftover stuff from the older stars. And so all the little points of light you see in this picture here are baby stars being formed out of that nebula. Let me see if I can find my other picture that actually shows the planets that are forming around those stars. Here we go. Can you guys see that image?
Yeah.
So that's a close-up image on some of those stars that I just showed you. And these big disks are solar systems. They're planets forming around new stars. And we think that our solar system formed out of one of these huge gas clouds about 6 billion years ago from the leftover stuff of a previous generation of stars that exploded and then just came all the way back together because of gravity and formed our sun and all of the planets going around it. Great question.
Thank you.
Alex has a question. Alex, can you hear me?
Yes.
What's
Go
your
for it, Alex.
question?
How do I actually forgot.
Oh no! Well, when you raise your hand again when you remember.
Colin, you have a question? Go ahead, Colin.
Why are there yellow planets?
I mean, why are there planets other than Earth,
Yes.
or planets around other stars?
So why are there just yellow planets?
Oh, why
Yeah.
aren't we the only planet? Wouldn't that be nice?
Yeah. Let's see. I got a picture.
So why are there yellow planets?
Yeah. So we think that all the planets formed together out of that big cloud of gas and dust I was just showing you.
2020.
And the stuff that was orbiting really close to the sun, that was where the heavier little rocks were, and they formed the rocky planets: Mercury, Venus, Earth, and Mars. Farther away from the sun, there was lighter stuff, mostly gases, and that's what formed the really, really big planets, like Jupiter, Saturn, Uranus, and Neptune. And as we've been discovering more planets around other stars. Sometimes we find planets that are just like this.
I know.
Small little rocky planets close to the stars and big gas giant planets farther away. But sometimes we also find solar systems where the big gas giant planets are really, really close to the sun. And we don't know why that is. There seems to be all kinds of different solar systems out there. Not all of them look like ours. Some of them do, but there are a lot that are really different. But we think they all form the same way, from those really big clouds of dust that we call stellar nurseries that give birth to new stars and all the planets that form around them.
Okay,
Great
Brooklyn,
question.
do you want to ask your question, and then Alex?
Okay, I remember my question.
Okay, go
again.
ahead, Alex, and then we'll get Brooklyn.
Wait, who's first? Me?
You
Or
can go first, Alex.
How do the clouds? How do those clouds get the broken pieces of the stars?
Oh, great question. So it's all about gravity. So let me see if I can find a picture of an exploding star here for you. Here's a good one. Okay, so this is a picture of a star like our sun when it runs out of fuel. And it just poofs out all its outer layers, all of its gas and dust out into space. And this big cloud of gas will just kind of drift through space until it bumps into another big cloud. And then just because of gravity, those two clouds come together and they get denser and denser and hotter until new stars start shining inside those clouds. And around those stars are these huge clouds of dust and gas. That's just the leftover stuff from the exploded stars. And so literally, like everything that forms the planets, everything that forms our sun, you and me, rocks, computers, all the stuff that we use to build anything used to be in the core of an old star that exploded a long time ago. And so we're literally star stuff, just recycled star stuff. And that process keeps happening all the time. We see new stars and new planets forming all over the Milky Way galaxy and in galaxies all over the universe. So we think the same thing happens everywhere. Stars are born, they shine for a long time, they explode, and then their leftover stuff forms into new stars and planets. And just because of gravity, that gas and dust clumps together and gets bigger and bigger. Just like you make a snowball or make a mud ball. You take little bits and stuff and you smash it together and it gets bigger. That's how planets form. Little bits of stuff sticking together just because of gravity.
Very
Great question.
All right, Brooklyn, are you ready? Brooklyn, can you hear me?
I have two questions actually.
Okay.
One of them is, has anyone ever got a piece of the moon?
Yeah, we have lots of moon rocks. The astronauts that went up there during the 1960s and 1970s brought back lots of moon rocks. And you can go to museums in places all over the world and you can actually see the moon rocks. You can't hold them in your hand. They're in special cases. But yeah, you can actually see moon rocks that we brought back from the moon. Great question. What's your other one?
In the daytime, is this weather or space? In the daytime, we see like these lines in the sky, white lines.
You mean like the kind of like the shooting stars you see at night?
It's like a cloud.
Contour lines.
Yeah.
Yeah, so those are lines left over from airplanes. So when airplanes are burning all of their fuel to go from one place to another, when that fuel combusts, when it burns, it interacts with all of the different gases in our atmosphere, and it makes that line of clouds right behind the airplane. So
Did
that's what
they
you're seeing
track?
there.
Do they track weather?
You know, some people think that they might have an influence on the weather, but we're not really sure. It's not a lot of stuff compared to the big clouds that are up there anyways. But yeah, I think over a long time, it could actually change the weather.
Okay.
All right. I think that's probably everybody.
They did a
All
great
right.
Dr. Sam, thank you so much for being part of this today.
Oh,
Yeah,
my pleasure.
Thank you. Give it a hand, boys
Thank
and girls.
you.
Thanks for having me. You guys asked great questions. So impressed with all the questions that got asked.
Miss Singer.
Yes.
They've had a lot. They've been looking
Oh,
forward
hold
to
on.
it.
I think there's one more. Patrick, did you have a question?
Is there still Pluto?
Yeah, it's still there. We just don't think it's a planet anymore. We call it a dwarf planet, but it's still out there.
Okay, is that good?
Thank you.
Thank you.
I have a question.
Oh, Javon, one more question from
Go
Javon.
for it.
Javon, go ahead. Javon, go ahead.
What is the name of the first star in space?
The first guy in space?
First star.
Star.
Oh, the first star. We don't really know. The oldest star that we know about is called the Methuselah star. And that star is just about the age of the universe. It's about 13.5 billion years old. So we think that might be one of the first stars. Yeah, Methuselah is its name. Great question. Yeah.
I have a question.
Okay.
In the day, are there stars?
Yeah, I can see a star right out my window.
Is that
You know which star I'm talking about?
The sun.
Yeah.
No, like stars those tiny stars.
I know, I was just joking with you. Yeah, there are stars up. The stars are up all the time. We can't see them during the daytime because of how bright the sun is. So all the light from the sun comes through the Earth's atmosphere, and then it bounces off the Earth, and it causes the sky to look blue. It makes the atmosphere look blue, and that blocks out all the stars that we can see during the daytime. But when astronauts are up in space, when they're up above the Earth's atmosphere, they see stars all the time. And if we could somehow block out the sun, like during a total solar eclipse, we'd be able to see stars during the daytime as well. Let me show you a picture of that. I think I've got one here. Let's see. Let's see.
You didn't get to ask a question.
See if I can get back to that screen. Yeah, there we go. And where's my eclipse picture? That's not it. Oh, here we go. Yeah, so here's a picture of the total solar eclipse that happened 3 years ago now. Oops. And I think if you look carefully, you'll see some little tiny pinpricks of light out around it near the edges. And those are all the stars that you could actually see right in the middle of the day when the sun got blocked out by the moon.
No.
So you can see the moon there. The sun's behind the moon. And up in the sky, there were stars all over the place during the middle of the day, during the eclipse. So that's what you have to do to see stars during the daytime. You got to block out the sun. And the moon's really good for that.
Keon, did you get a chance to ask your question?
I did. I just can't see the picture. Yes, I did.
Oh, you can't see the picture? I wonder why. Okay.
Okay.
I saw your hand up.
I just see Sammy's. I just don't see that picture of it.
Okay.
Okay.
All right. Well, Keon, do you have one last question for Dr. Sam?
Okay, I'm done.
No? Okay. All right.
All
we're good.
right. Oh, Kellen's got his hand up. Kellen, you have a question.
Yes. Can you see Can you see the sun in the? Can you see the moon in the daytime?
Yeah, you definitely can. So every month, for about half the month, the moon is up during the nighttime. And then the other 2 weeks of each month, the moon is up during the daytime. You just need to know when to look. So it's usually around the time when the moon isn't really big, or right around the time that it's really big, when it's full, on kind of the two ends of the spectrum, when it's really small and when it's really big. It's up during the day. And so, yeah, you just need to know where in the sky to look, but it's up there for half the month.
Sam,
I have a question.
I have one too. Sam, we had a supermoon last night and they said we're not going to have another one in 2020. Why is that?
Yeah, so the supermoon is, it's actually great that people are paying attention to this. It all started several years ago when there was a website that said the moon was going to be bigger up in the sky than it was going to be for like 20,000 years.
Right.
And it's true, but not much bigger, maybe 1% bigger. And so a supermoon is when there's a full moon. So when the moon's biggest in the sky, we can see the full disk of the moon, and when it's at its closest approach to Earth. And that doesn't always line up at the same time. Sometimes the moon is at its closest approach to Earth when the moon's new and we can't see it at all. So when the moon is full and it's at its closest approach to Earth, that's a supermoon.
Got it.
They happen every year. And some of them are just a little bit bigger than the other ones. So we've had the biggest one that we're going to have for the rest of the year.
Got it.
I have a question.
Okay.
Is that Daniel?
Yes.
Okay, Daniel.
So, where does sulfuric acid in Venus's atmosphere come from?
That's a great question.
This is my first graders.
We don't really know for sure. Some speculation is that there are a type of volcano on the surface of Venus, and acid comes out of the volcanoes. That's one possibility. It may have also just built up in the atmosphere over a really long period of time, just how the different gases in our atmosphere built up. But we don't really know. But there is a lot of it there. Venus would not be a fun place to hang out.
Because of Venus's hotness, it can take some reflection of the sun's heat.
That's right. Yeah, the clouds are so thick on Venus that a lot of the sun's energy gets trapped at the surface of Venus. It's called a runaway greenhouse effect. And so the surface of Venus is about 900 degrees Fahrenheit. You could melt lead. You could melt metal right on the surface of Venus. But really high up in the atmosphere of Venus, near the top of the atmosphere, it's actually more like the atmosphere on Earth. So there could potentially be life really high up in the atmosphere of Venus.
Wait a second.
Great question.
All right, thank you.
I have a question.
All right, Miss Singer, anything else?
I think.
Yeah, it'll be
I'm happy to answer a few more questions if we got time.
Okay, we
have a question.
Oh, just a minute.
Hold on, hold on.
Wait till you're called on, please.
Who was the one who asked? Jonya, you asked if you said you had a
Yes,
question.
she's
Okay,
got
go
her
ahead.
hand up. Go ahead, Jonya.
This is taking so long.
Cade, you can leave if you want. Go ahead.
Jonya, go ahead and ask your question, honey.
How many miles is Pluto from the sun?
Ask that one more time.
How many miles is Pluto from the sun?
Let's see. It's about 60 astronomical units, and each astronomical unit is just under 100,000 miles. So it's about over 60 million miles away.
I have.
Oh no, sorry, 60 billion. Sorry, 60 billion miles away.
Wow. 60 billion.
That's
All right,
far.
thank you, Jonya.
I have two
Million, 6 billion. Gotta get my math right.
Javon,
Because they're going to check you later, Sam.
all right, yeah.
I have a question.
All right.
Yeah.
Sophia?
So when the moon blocks the sun in the eclipse, how does the moon go out of the orbit of orbiting Earth?
Great question. It stays in orbit. So the moon is a lot closer to us than the sun is. The moon is about 400 times closer to the Earth than the sun is from the Earth. And the moon is about 400 times smaller than the sun appears from the Earth. And so when we see the sun and the moon in the sky, they look like they're about the same size. One's a lot closer and a lot smaller, the moon, and the sun is a lot farther away and a lot bigger. But because those distances and sizes match up, they look like the same size in the sky. And so the moon can actually pass right between the Earth and the sun. And when the moon passes perfectly right between the Earth and the sun, then we get a total solar eclipse. Great question.
Wow. Good, thank you.
I have two.
Javon, did you have one more?
Yeah, I have two questions.
Oh, just ask one right now, buddy. Okay, go.
Do asteroids produce fire?
So the question was, do asteroids produce fire?
Yes.
So you can't have fire out in space because you need oxygen, what's in our atmosphere, to make fire. So you can only make fire on a place like Earth.
Oh.
Out in space, you can't make fire, but you can make light. And so some asteroids can reflect the light from the sun, so we can actually see them. But then when asteroids come through the Earth's atmosphere, they get really, really hot, and they start giving off even more light. And so that's when we can really see asteroids, and we call them shooting stars, when we see them burn up in the atmosphere. So it's not the same type of fire that we have on the Earth's surface, but they give off a lot of light as they disintegrate up in the atmosphere. Great question.
All right, Evelyn, you have your hand up. What do you want to ask?
I
Quickly.
have another question.
Evelyn?
Only close to their muscles get weak.
Wait, can you say that louder and slow down?
If astronauts only close to their muscles get weak.
Do their muscles get weak?
Yeah, so when astronauts are in space, because they don't experience gravity, they don't have to use their muscles as much to move around. And so their muscles can get really, really weak if they don't do a lot of exercise. So when astronauts are up on the International Space Station, they have to exercise every day just to keep their muscles working. Great question.
Good question, Evelyn.
Good question, yeah. Okay.
Sam, you must be thirsty.
I got water right here.
Okay. Okay, it's quiet. I think that's it.
Okay.
Boys and girls, if you have questions in the future, you can always give me or Mrs. Gregg your questions, and I'll send them off to Dr. Sam and get an answer for you.
Yep.
Okay?
Happy to answer more questions later on.
And I'm going to give them all your website so they can watch some of your videos, your weekly videos.
Sounds great.
Great.
Okay? We'll pass it on.
That's fun.
He has a weekly video presentation on Facebook.
That's awesome. We can't thank you enough.
Oh, it's my pleasure.
Boys and girls, what do you say to Dr. Singer? What do you say?
Thank you.
You're welcome. That was a lot of fun.
It was a lot of fun. They really learned a lot. We're
Yeah,
very
thanks for all your great questions.
Bye, Kellen. Bye, everybody. See you in the morning.
Later.
Bye,
Go ahead and
guys.
sign off. Javon, you can sign off now. Bye.
Bye. Bye, Sophia.
Bye.
We'll see you
Bye,
later.
Sophia.
Bye.
Bye.
Bye, Sophia. See you later. All right, Javon, Janya, you need to sign off. Thank you. I don't know, Miss Singer, do you?
I can do it. Yep, I can do
Okay,
it.
that sounds great.
Anybody who doesn't want to leave is going to
There you
get.
See you later.
There you go.
We can keep the good people here, but let's get. No, I'm kidding.
I can't thank you enough. This was amazing. I told Natalie, Sam, that you have teacher blood in you because you did an outstanding job. I mean, they were so into it. It was like they were sponges taking everything in. And I
Nice.
just appreciate it. Yeah, we were supposed to go to the planetarium, and and our field trip got canceled. So we were so bummed. And
Yeah.
I talked to Natalie, and she goes, "Wait a minute, I have an idea." I was like,
Ashley, do you have any questions? Ashley?
Hi. No.
Hi.
No, that was amazing.
I'm surprised you don't have any questions.
Well,
So cool.
I took an astronomy class in college, so I
Know everything.
know everything.
She thinks she knows everything.
No,
She was
but-
amazed.
Yeah, I was just like sitting here like when we were talking about like billions and billions of planets just in our
Trillions.
just in like
Trillions.
The trillions of solar.
Or the
Sam, I have a great idea for you. I think you should do a summer camp, virtual summer camp.
I think so.
Yeah,
Yeah.
maybe.
I really do. Like, I think
Yeah.
these kids all over the country would just love it.
They would.
They were these kids don't sit still for anything, and they were so engaged.
Oh, I was like,
Nice.
why so many
We
questions?
can't get them to sit still for like a 10-minute Zoom
No, they really.
day for this
He
hour.
used to teach
It's incredible.
preschool, so he's got the.
Yeah, you're a good teacher.
Yeah.
Not
Nice.
only that,
Excellent.
not
Yeah.
only that, but he used to jump around in his classroom too.
All right.
Only that.
No, he
Yeah,
did. He
I was a little
lovely.
squirrely when I was young.
And his father's here to tell you the truth.
It's the truth.
I think all boys are.
Great job,
Yeah.
Sam. Thanks, Natalie.
My pleasure.
Thank you guys for coming. It was really fun. It
was great.
Yeah.
We're out of here. Talk to you later. Bye.
All right,
Bye.
bye.
Bye. I'll let you guys go. You can let me
All
know.
right, we're out of here. Sam, I'll see you on
Thank you so
Sunday
much, Sam.
morning.
Yeah,
You know
see you
what?
then.
Don't be surprised if you get some letters. I might have them write letters.
Sounds
They
good.
might even have a question for you on that. But
Oh
thanks
yeah,
again.
I'm happy to answer any questions. Yeah,
All right. Thank
Thanks
you.
so much.
you're welcome.
Bye. Thanks,
Bye.
Yeah.
Bye, Sammy. See you Sunday.
Sunday,
Bye,
Mother's
buddy.
Day.
See you then.
She's got a special surprise for you.
Oh, nice.
Yeah. See you. Thanks again, Sam. I'll talk to you later.
All right.
All right, sounds good.
Bye.
Bye-bye.
Bye.
Okay, guys. Oh, Sam?
Yeah.
Sam, how do I do this video? I got to stop it and then do what?
So did you select record on computer or record on the cloud?
I have no idea. I just hit record and I didn't do it when you told me to.